So this is part 2 of the naming notes. Today we're going to be doing ionic compounds. And I'm going to be honest, the writing of the ionic formulas is a little bit more complicated. The naming is not, but the writing is. Okay. So remember the pink sheet and all the ion quizzes we took? That's where this is going to come in handy. That's why I did it when I did, so that you would hopefully have those things memorized. So you're going to definitely need your pink sheet out to do all these. Okay, so let's start with the rules. We're going to start by writing the formulas first, and then we'll do naming. Okay? So when we are writing formulas, there's a couple of rules that we need to remember. Remember, ionic is a metal and a nonmetal. So for binary ionic compounds, and binary ionic compounds means a metal and a nonmetal together. Okay? So binary is going to mean metal and a nonmetal. So we have one metal and one nonmetal only. Okay? So steps to this are the cation, which is positive, always comes first, and the anion, the nonmetal, is always second. Okay? Second thing is you're going to determine the smallest whole number of ratio of cations to anions that would make the charge equal 0. Because remember, they're electrostatically attracted, but they're neutral when they're together. Determine the ion formed in the main group of elements. Look for its placement. Remember, many of our transition elements can have multiple charges through groups 3 through 12. So you're going to have to just memorize these. That's where we had them on the sheet. Okay. The good thing is it's going to give you a Roman numeral to be able to tell you which one you have. Okay, so hydrogen is kind of one, remember it's placed at the top because it's its own unique properties. So it's one of those funny ones that can either gain, lose, or share, okay, depending on the other elements when it combines, okay. So if it gains, it's going to be a -1, but if it loses, it's going to be a +1. So you just have to see what's going on. All right, so here is an example. I'm going to start with the easy one, and that is sodium chloride. We know that sodium's charge is a +1. We know that chlorine's charge is a -1. So they're literally just going to go together in a 1-to-1 ratio because now their positives and negatives are equal to each other. Aluminum and oxygen are a little bit different. Okay, aluminum has a +3 charge. Oxygen has a -2 charge. So we have to figure out how would those go together. So I would look at that and say I've got a multiples of 3 and 2, so let's make it be +6 and -6, okay? And so aluminum, I would need 2 of them, and oxygen, I would need 3 of them, okay? So let's practice this, okay? So we're going to start with magnesium and phosphide. So while we're getting started, it's best to write the charges down, and then you can look at them. Later on, you'll be able to just look at charges and figure out what they go together. You don't have to write them separately. But for now, let's write them separately. And I'm just going to randomly pick some of these. I'm not going to do all of them. So magnesium is a group 2 metal, and so its charge, or its ion, is a 2+. Okay? Phosphide is in group 15. It needs 3 valence electrons, and so it's going to take 3, so it's going to have a -3. So in order to put those together so that it's electrically neutral, I'm going to need to have a total charge of a +6 and a -6. Okay, so that means I'm going to need 3 magnesium and 2 phosphorus. Okay, let's look at iron 2 bromide. So iron 2, this is telling us, it's not telling me that I have 2 iron, it's telling me that my iron is a +2 charge. Remember when you did the ion quizzes, you had to put the charge that had the Roman numeral. So iron is a +2, and then bromine is a group 17 halogen, so it's going to be a negative. Okay? And so in order to get that to bond to be electrically neutral, I need my negatives to equal my positives, so I'm going to need 2 bromine to go with 1 iron. So my formula would be FeBr2. Okay, calcium oxide, if If I look up calcium, it's a group 2 metal, so that means it's a 2 plus. Oxide is in group 16. It needs 2 electrons. It forms a negative 2. So they are already electrically neutral, so I'm going to just say CaO because their charges already bounce. Okay? Now let's look at sodium sulfide. Sodium, group 1 metal, so it is a +1. Sulfide is a minus, or 2 minus. I did that backwards a while ago, sorry. So if you look at that, I have 1 plus and I have 2 minus. So I'm going to need 2 sodium to equal up the opposite charge of sulfide. So it'd be Na2S. Okay. I'm going to skip down here to lead 4 nitride. Lead 4, that means that my lead has a +4. Nitride is in group 15. It will take in 3 valence electrons, so it's a 3 minus. Okay? So what would I do there is I would do a multiple of 4 and 3, which is 12, because I want each side to be a 12 plus and a 12 minus. So I'm going to say Pb3 nitrogen 4. Okay? So what I would like you to do here is I would like you to pause the video and see if you can't get the rest of these. Alright, so take a moment to check your answers to see how you did on that. So you might want to pause the video again and double check to see if you did it and see if you can kind of see if you did them correctly. Great, move on. If you didn't, you can kind of take a few minutes to like look at that and look at your charges and seeing how they are supposed to go together. So with that, I'm going to move on to the next slide. So the rules for writing what's called ternary ionic compounds, and ternary means that there's more than 2 things. It means we're going to include those polyatomics, okay? And that is something that is imperative that you're going to know, okay? You're going to have to just memorize them. If you didn't, I know you memorized them for the quizzes, but I also know that you memorize and forget. The better you know these things, the easier your life will be in here. If you're constantly having to look up that the charge of a sulfate is SO4 and a 2 minus, then it's going to make your life more difficult. So let's just get them memorized, okay? If you recall from our bonding unit, polyatomic ions are bonded together, okay? So they are covalently bonded, but they have a charge. So they're going to act like an ion. Okay, so same rules as before. We're going to write the cation first and the anion second. Okay, so then we're going to determine that smallest number of hole ratio just like we did before. So in this case, we have sodium phosphate right here. And so we want to see sodium has a +1 charge, phosphate has a -3. So it takes 3 sodium to go with 1 phosphate. Okay, and the next one, I have ammonium sulfide. Okay. And ammonium is an NH4 +1, and sulfide is a -2. It's going to take 2 of these to go with 1 of the sulfide. So when I have a polyatomic ion and I need more than 1 of them, I put these parentheses around and I put the subscript outside of it. So that means that I have 2 of these entire covalently bonded polyatomic ions. Okay. On our pink sheet we put brackets, and I told you you don't have to write the brackets because that was just to let you know that the whole thing has the charge. But when you're putting it in a formula, okay, you have to put only the parentheses if you have more than 1. So let's do a couple of examples and see if it helps you out a little bit. So we're going to start out with aluminum sulfate. This is where that pink sheet's going to come in handy. Okay, so we know that aluminum is a +3, right? So we'd write down aluminum as a +3. Hold on, my video just paused on me. Okay, I think we're back. So we have aluminum is a +3. Maybe. My video is... All right, sorry about the technical delay. Aluminum is a +3 for the third time here. And then we know that sulfate is a SO4 with a 2-. So same thing, we're going to look at those charges and we're going to realize I got a +3 and a -2. So I'm going to need a multiple of 6. So I need aluminum to be +6, so I'm going to use 2 of them. And I need sulfate to be total of a -6, so I'm going to use 3 of them. So then I'm going to use those parentheses, SO4, 3. And so that would be the formula for aluminum sulfate. Okay? Potassium, K+, chlorate is ClO3-. So I already have a +1 and a -1, so it's just going to go together, KClO3. Okay? How about copper 2 acetate? That copper 2 is telling me that copper is a +2 charge. Okay? Acetate is C2H3O2 with a -1 charge. So since copper is a +2, acetate's a -1, I'm going to need 2 acetates. So it's going to be Cu parentheses C2H3O2, 2 of them. Okay? Plumbous nitrate, don't worry about that. We don't learn the old style system, so just mark that out. Iron 3 oxalate. So let's go with iron 3 is Fe3+. Oxalate is C2O4, and it's a 2-. So we're going to do that multiple of 3 and 2, so we need 2 iron, and we need 3 oxalates. All right, let's do one more. Let's do, and then I'm going to have you fill in the rest like we did on the last one. So 10, 2+, because it's 10,2. Hypochlorite was ClO-. So I'm going to need 2 hypochlorites to go with 110,2. Okay? So pause the video again and try to do the rest of those. Okay, so check your answers and see how you did. This would be a good time to pause it so you'd have time to check it. Actually, I'm going to stop the video here because the worksheet that you have for this naming ionic and writing formulas, on one side you have naming and on the other side you have writing formulas. So what I would like you to do is today, I want you to just practice writing the formulas because quite frankly it's the hardest part. So we're going to end the video lesson here and then we'll pick up tomorrow with how to name them, which I promise you is a little bit easier than writing the formulas. Okay?